So next, we are moving to looking at expanding analytics capability with Michael, who's founder and CSO of Invenium, which I probably pronounced wrongly, which is the subsidiary of A1, the Austrian operator group. Okay, over to you, Michael.
So thanks a lot for introduction, and thank you also for invitation to have the talk about one topic we're dealing here, especially in Austria, but also in the other countries of the A1 Telekom Austria. And what I'd like to tell to you is a little bit the story of Invenium Data Insights, how it started, how it's going, from where we are coming, and what we are now doing in such a big telco like the A1. And in the area of the digitalization, and also in providing digital products in this case, what I would say. The story from Invenium started now around about 9 or 10 years ago. I'm from my background a transportation engineer. I'm also at the Graz University of Technology, where I'm dealing with transport demand models, really where people are moving from one municipality to another municipality, which people activities do they have, and which transport mode, for example, they use. And the idea was really I was building such macroscopic models based on surveys, so data surveys. People were asked what you're doing the whole day, where you're at home, where you go to work, where you have a leisure time, and so on, and which transportation mode you're using. And we said, okay, there should be the possibility also to take some empirical data, for example, also from telcos, because if you have your smartphone or your phone with you, you have over the day the wave path. So the smartphone is doing the same what you're doing or what people are doing. And we said, okay, this could be a possibility to use this data to calibrate our transport models in this case. I went to A1, this was now 9 years ago, and we started together in different research projects. We said, okay, yeah, first step, we can use the signaling data of smartphones. I will, in the next slide, I will tell a little bit more about it, and take this data and calibrate and validate the traditional transport models. Then we also did the research project between 2013 and 15, where we analyzed the topic. It is also possible using the signaling data of a telco, of a network telco, also to use it in a way not only for scientific work or for research projects. Is it also possible to use it in a commercial area in this case? And we developed together an anonymization algorithm where it is also possible to use this data also in the way for different branches and also for the business in a telco in this way. Then we started at the end of 2016 to bring the topic from the world of the science area, where we built a scientific prototype, I would say, also to bring it in the business world, also to bring it into a telco, and to build some products and also projects. We started as a spin-off of the Graz University of Technology, and we said at the beginning, okay, the A1 was, we started here in Austria, A1 was not only the data provider in this case. They also said, okay, we will get into the company, really with 20% share in this case, also to, explore the topic, also to bring it to the market, also to do the sales process in this case, because A1 has the data, we have on our side the analytics capabilities, and A1 has, for example, also the possibility to sell in the B2B market, where is the biggest provider also here in Austria. And we said, okay, let's go together, let's start the topic. Is it possible from the scientific world with research topic also to bring it to the customer and to generate revenues in this case? And why I'm here now is also we're doing this now for 4 years, I would say, really on the market, not only in Austria, also in Slovenia, Serbia, and Bulgaria. And the good thing was the revenue is coming in, I would say. The market works in this case. And in the last year, during the Corona crisis, A1 said, okay, to bring the business also to another countries, to another telcos, and also in the market to get bigger and to scale it up. A1 got a 50% share of Invenium, so now we are really a daughter of A1, but also the founders, my 2 colleagues and I, we are also in the company. Also, we said, okay, we'll stay in the company to develop the business for the future also together in this case. So this is a short story about Invenium in the backside, I would say. I will give you now a little bit a technical overview. What is the data we're dealing with, and also what we're doing with the data in different products and also in different projects, for example. I will tell you the story now for Austria. Also, the technical informations behind are from Austria, but you can do the same topic also in the other footprint countries of the A1. So what we are using is the signaling data of the telco network. So we are getting the circuit switched and the packet switch data of the 3.2 million smartphones here in Austria, or the phones here in Austria. And each phone, if they have a connection, I think everybody of you knows, they get a mobile phone event, and this event has a coordinate and also a timestamp. And based on the coordinate and the timestamp, we are dealing with trajectories over the day. So the smartphone is moving in around over the day, and we are using the information to develop different algorithms in this case. The first step is, for example, if you're moving over the day, where you have stationary segments, where you're, for example, at home, where you're at work, where you have your leisure time, where you're shopping, and so on. And all the segments between the stationary are moving segments. And we developed different algorithms also together with different machine learning algorithms to implement meta information, to implement, for example, the real timetable of the public transport operator in this case. We developed an estimation really to know which transport mode is behind. So really to have the whole information of the people of the whole country, also integrated, for example, with roaming customers, where we analyze tourist information and so on, and provide then at the end of the day the customers dashboards, data solution products based on this analytics. We said at the end of the day, it's really important for customers to turn this raw data, I would say, into some insights and give the answers of different questions they have. So what you see here on the slide, for example, is really the whole story of Invenium and the platform behind. We are collecting the data. The A1 is also the part which anonymize the whole collected data of the network system in this case. This was really a long process to bring it into a platform which is agreed also from the legal part in Austria. We are also really certificated by the TÜV in Germany in this case, really, that the whole process from the raw data, anonymization, and then really the analysis topic from our side, where we implemented our algorithm and so on, is processed and audited by the TÜV, for example, in this case, because at the end of the day, we are only providing analytical results in this case, aggregated analytical results in the different branches in this case. And we built the platform on our own in this case. So we have really from the raw data, the analytical topic, and also the visualization in the front end, and also the data providing topic based on APIs and some platforms and so on. So we are dealing with the whole topic and providing it really at the end of the day to the customer in this case. Then what is the raw data, for example, in Austria? Because we have always the discussion, okay, the data we're using here, it is really analyzing the whole demand of the people, for example, of a country. In Austria, A1 has around about 42-33% of the market share here in this case. We have different brands in the family of A1, I would say, based on the whole attributes of the socio-demographical part we have here in Austria. We have, for example, Bob. Yes, this is more for younger people in this case, and A1 is more the part for a little bit not older, but the topic in the average year of the Austrian population. And what we're then at the end of the day are doing, we're taking this raw data brands in this case, we're using the network data, we're analyzing it. We are also including the roaming data, which is roaming, for example, which telco providers are roaming in the Austrian topic here, and extrapolating the results, for example, for visitors of a shopping mall on the whole population in Austria. So we developed extrapolation factors based on this market shares we have here in Austria. And at the end of the day, we're calling the product, for example, here in Austria, A1 Mobility Insights, really to have a new possibility to analyze every day the traffic demand of the people in a country, for example. As I said before, we are now on the footprint of A1. And we're started now around 4 years ago here in Austria, where we started really with the scientific prototype. And 3 years ago, we also went to another opcos in this case, for example, Slovenia and Serbia, and now we are also in Bulgaria on the way. These are the countries in our international network of A1. But we will start this year also with the funding of A1 in other European countries in this case, to bring the topic, which works now quite good in Austria and generating also quite good revenues here in Austria, to other European countries in this case, to work together with other telcos. Understanding mobility is the really background in this case, I would say. And we said from our side, okay, we will divide the topic in different business areas and also in different products in this case. For example, where we are with our products on the market, for example, in business areas, is the focus topic is transportation insights, or the transportation area, where we are analyzing based on this mobile phone trajectories over the day. For example, how the individual transport works, how the public transport works in Austria. For example, we have here in Austria, one of our customers is the national railway operator. And in Austria, if you're buying a ticket, for example, you can take, for example, the train in the morning or also the train in the afternoon. So it's not fixed on such a train. But what we are doing then is really we are analyzing every day, around about 3 years, since 3 years in this case, every passenger exit of a train, where people are entering and exiting a train, for example, where they are coming from, what is the home location, for example, what is the work location before, really to analyze 1,000 train stations in Austria and have the whole information where the transport demand is. For example, what they're then doing is, how my offers in future could be, how is the information before, for example, the train station, where are people coming from, what are the origins, what are the destinations, and so on. Really to have the whole information of the transport demand in the world of, for example, the railway national operator. Then we are also dealing, for example, in case of that, we're analyzing how many cars and also pass-bys, for example, are on the road in this case. We're analyzing this every day. The basic algorithms behind we are dealing with is, for example, we take the road trajectory, because the accuracy of the network is not as accurate like GPS. I think everybody of you knows this. But what we are doing then, we are filtering. We have different algorithms really to bring this raw trajectory, for example, on the road based on map matching algorithms and so on. And for example, also one customer in this case could be OMV is one of our site. We're analyzing where people are passing such point of sale. This could be every point of sale in this case in the Austrian network. And for example, also if you're combining this with some customer information, they give you, for example, the revenue information or how many people really entering such a point of sale. You can analyze drop-in rates and so on. You can compare it with different stations and so on. So you get a really quite good overview, and you get this overview every day. And also, for example, for a historical period in this case. We are also in the area of, I would say, digital out of home. This is now some advertising topic we started last year ago. There is always the question, how many people are looking on such a digital out of home? So the information is then, you can monetize it, how much you have to pay for such a billboard, or in this case. And based on this digital out of home project from our side also, we started 2 years ago to get the consent of the customers of A1 here in Austria. So we said, okay, it is possible to use, for example, some socio-demographic attributes like men, women, or for example, the age, and also to bring it as an additional information to the technical stream, the signaling data. And then at the end of the day, for example, then it is also possible from our side, not only to give the frequency, how many people are passing, for example, such a digital out of home, it's also possible which age do they have, for example, if they're men or women in this case. Really to have an additional information based on socio-demographic attributes in this case. What we are doing, because my world is from the background from the scientific area, and we're still working a lot of in this R&D topic to bring also it to research projects. We have national research projects, especially in the field of transportation. Now, a focus topic is really, I think, in every European country, for example, the cycling detection. Is it possible, based on our information, have really the knowledge where people are cycling, where do they have the origin, where do they have the destination, and also at the end of the day to have the knowledge and then to optimize infrastructure. And we already know infrastructure is a very important topic, and also a topic with a big budget. It's quite interesting to have a monitoring system, for example, based on our telco data, to bring it to relevant stakeholders, in this case, to cities, to countries, to governments, and so on in this case. And on the other side, we said, okay, we have to standardize our projects and bring the projects in the products. And we developed now 4 products in the last 3 or 4 years, I would say. The first topic was such an event location. We're analyzing a location, visitor frequency, customer potentials, and so on. I will step down in the next slides a little bit deeper in this case. For example, we're analyzing every big shopping mall, for example, in Austria here, where people are coming from, how is the dwell time, and so on. One topic we also developed is, what is very important, for example, also here in Austria, is tourism insights. We already know, as I said before, the roaming customers here in Austria, and then different tourist agencies said to us, is it possible to divide it, for example, that in Austria, for example, in Vienna, the people from Russia or the people from Germany or the people from Britain, do they have different moving patterns here? Do they visit, for example, at first sightseeing Schönbrunn in Vienna, for example, and then the Stephansdom, and what they are doing before, what they're doing after, really to have the information of the demand of the tourists, and at the end of the day, to bring better marketing, to bring better offers, and so on in this case. The third topic we developed was city insights. There was always the question from city planners and also from transport planners of the cities. What are people doing in my city? I do not know. I'm building, for example, I don't know, a new shopping center. I'm building a new area, for example. People will live there, but what will they do over the day? The goal of city planners is to bring the people where they live. They also should have their education there. They should have the possibilities for leisure. They should have the possibilities for shopping. They should have the possibilities, for example, also for work in this case. And all this information should be built, or the possibilities should be built in, for example, such a district here. But we have to monitor it. And is there a monitoring system which is possible to do this? Not now, also in future, and based on the information of now, also to provide it, for example, in the forecasting for the future. And this is what we built. We're analyzing based on districts or smaller areas, what people are doing, where they move, and which activity do they have. And the last product here is Retail Insights. This is a product which is more an analytical project, not based only on the telco data. It's more also to combine it with data of retailers, really to get his KPIs, to get his informations, to get his data, to combine it, and at the end of the day, really to have an assessment possibility. For example, I will build some new stores where the hotspots, where the white spots. If something will change, for example, in my point of sale, what will happen? Really to have it more on the bigger scalable area, more really not only for a microscopic area, really for example, a whole country or a whole city in this case, I would say. Yeah, this is what I said before, I would say. And then only some visual impacts, what we're doing and how we provide it, for example, to the customers. Event and location insights was our first product. We're analyzing on, for example, a city center or a shopping mall, and what is the information where visitors come to my station, for example. You can define, for example, also the dwell time there. You can analyze it, you can filter it. How long do they stay, for example, in my city center? What they are doing before, what they are doing after the topic. What is the demography behind, in my case, and how it, for example, works over the history, how it works now. If I will do some marketing topic, how it works, how it changes, and so on. This is, we built it on the topic here, and we called it, for example, location and event insights. We have a lot of customers also in the event area, not now during COVID, but what we see now is really, we're hoping, everybody of us is hoping in and near ending, based on the pandemic situation, that a lot of customers are now really interested in, okay, if I will have a new event, I will really buy your product, in this case, to monitor what happens in my area here, in this case, for example, in case of visitors. Tourism insight, I said before, we have a lot of customers, different communities, regions, also federal states here in Austria, and also areas where we are analyzing really the activity of people. We have different points of interest in a tourist region, in this case, and we are analyzing what people are doing there. How is the distribution here? What are the impacts of different seasons, months, of days during the week, on the weekends, and so on, really to have the whole information to provide tourist agencies what people are doing with different profiles, in this case. Yeah, I will jump on this. And then City Insight, I said before, is one of our new products in this case, and there is really the information which is very interesting for city planners and also for transport planners. What is the mobility? What is the mobility, the volume in my city? What are people really doing? From which area they're coming? And it's not only possible for example, for the city here. You can also analyze the inhabitants of a city, what they're doing, for example, on the weekend. Do I have a lot of parks in my city, but they do not have some visitors from the city because people are moving to another city, to the green field out of this case, and really what residents and inhabitants of a city are doing, where do they stay, and what is the possibility also for a city planner to have a measurement system here, and also for example, to change some topics if something does not work in this case. This is also a very crucial point, I would say, at the end of the day, to give answers also that city planners or stakeholders in this case can do anything with our outputs, I would say. Transportation insight, I said before, this is really our biggest case in the topic here. Only as an additional impact, we're dealing really with the whole information of every train station in Austria. We have around about 1,100 train stations, and for example, if some infrastructure builder like the national operator in Austria, the ÖBB, if they're investing in some expansion of some infrastructure, a lot of money is needed in this case. And for example, in the last year during COVID, we were the only counting system here really in Austria, which provides to the CEO of the ÖBB here in Austria every day the information how many people are traveling with the train here in Austria. And we said, okay, how was decreased? We had, for example, in the first 1, 2, or 3 weeks, around about 95% of the passengers were decreasing in this case, and we were the only system which monitors it every day and provide the result every day, for example, to our customer in this case. What was, I will jump to the next slide here, what we also did then, and this brings me also to the end, I would say, of my presentation, to give you a short overview. What we're really doing is, last year we started on the Friday in March, where in Austria the pandemic situation started, I would say. and we said, okay, on Monday we will have the first lockdown here in Austria. This was in the middle of March last year. And the Austrian government said, okay, we need the information, what people are doing, where they're moving. And then we said from our side, okay, there could be possible to provide the Austrian government, also the Ministry of Health, because they are building some epidemiological models where they are analyzing the effect and also the rating of the COVID cases in this case. And we said, okay, we can provide the mobility of the people, and we will give you every data information. Okay, does the lockdown works, where people are moving, from where people are moving. And so we built internally a daily mobility monitoring system on a municipality level, for example, in Austria. And we're providing this every day, for example, also to the Austrian government, to, on the one hand side, to have an information how the lockdown works, but on the other hand side also to bring this data or this analytical result as an additional data information to the epidemiological models of the government here in Austria. And this was also one topic from our side where we get a lot of media coverage, I would say. And the first step, we said we are not so interested to have too much media coverage. And also the A1 said, okay, let's see what happens or not in this case. But at the end of the day, the preparation of 6 or 7 years before with the topic of anonymization of the data, of the raw data, really the whole process in Invenium is included in the A1. We got a very, very good publicity in this case. And we were, I think, every second day in a lot of newspapers, in the TV and so on. And a lot of media is talking about us. So that at the end of the day, we are turning a topic. We are not Big Brother. We're analyzing the transport demand of people to give the information to the government, to retailers, to our customers. Also, at the end of the day, for them to bring better offers to the people here in Austria and also the other countries where we are on the way. That's the story, I would say, about Invenium. Thank you.
Okay, Michael, thank you. We have a couple of questions for you here. And one is asking if you're allowed to collect all of this information. The questioner says they realize it is anonymized after it's collected, but what about governments and regulation in Europe? And especially, as you said, you differentiate different culture segments and people's moving patterns and things.
The topic is that really the raw data is anonymized by A1. And I think it's always a little bit the topic that people do not really know how these moving patterns, for example, are really looking. So it's not GPS data, I would say. We have, for example, in the city center, you have an accuracy of the raw data between 0 and 200, 300 meters. But for example, also in the rural area, there could be the accuracy between 0 and 1 kilometers or 2 kilometers in this case. And what we are really then doing at the end of the day, we're taking this raw data, we're filtering the raw data, and then we're modeling results. So we are not dealing with the raw data, we're building some, I would say, agents based on some synthetical data, I would say. And at the end of the day, we are putting all these data sources together, and at the end of the day, customers only get the modeled data. And this whole process from the raw data, anonymization, aggregation, modeling results is then in the regulatory, what is allowed also from the Austrian government and also from the TÜV in Germany at okay, evaluated and audited.
Okay, and we have another question, and that is A1's market share is about 37%, I think you said, in Austria. Are you planning to work with the other two main players, Magenta and Dry, to reach a higher penetration rate and reliability of your data? Because maybe you attract a certain demographic of customer, which would give you somewhat of a slanted view of the overall market.
Yeah. This question is always coming to our side. This was a discussion at the beginning where we built Invenium, I would say. But at the end of the day, we said, okay, with the big sample, you have it here, and we have, for example, really realistic people which are moving. We have around about 35 to 40% of the Austrian inhabitants, and we took a lot of time to extrapolate it on the whole population, and we said, okay, this 1, 2, or 3% getting better if you have the whole coverage. It's not really needed in this case. And also the other topic, you have to bring all the customers, all the telcos together really to provide the data to you. And I think that's also not so easy, I would say. But the result will not really be such better because we are always in such a macroscopic way.
Okay, Michael, you have a big compliment here on a fascinating presentation by our next questioner, who says, do you think 5G will increase the commercial opportunities for Invenium?
I think there is a topic. The 5G is a very important topic also for us. But the topic is also in this case to see on the one hand side what is possible. The delay is different. We're starting now different research project in the area of 5G. On the one hand side, if it's possible to get in such a near real-time area, because this is also very important for us. The delay time is important to provide results earlier. And the other topic is also the accuracy. But also what we are internally discussing now is based on the accuracy, how the anonymization works, because there could be also a possibility that we need an additional anonymization in this case, because the accuracy of the raw data is better in this case. And this is what we are internally discussing and what we will see will happen. But I think this will take the time, the next 2 years, and then we will see what, but it's quite interesting data source for us for the future, yes.
Okay, and we have a final question, if you'd be so good, Michael.
Yeah.
What, if any, data do you link into your models from government bodies or other organisations that are publicly available? And are there some good government data that are really useful?
The topic is that we're modeling for us, for example, here with the national railway operator, we get from the national railway operator the information of the real timetable. So for example, this is in this project one of the real crucial points. What we, for example, are getting here in Austria is we're working together with the National Statistics Institute. We're getting the information, how many people are living in an area, how many people are working in an area. It's always needed to see how the quality of the data is. But it works quite good, and it's quite a good additional data source, and it's also very important to have an additional data source because all the machine learning algorithms are working with additional data sources. If you're working together in projects, it's quite good. It's quite good to get the information, but you always have to evaluate it, how it works or it works not. Because otherwise, if the training data is not good enough, the fault is as the training data is, I would say.
Okay, Michael, thank you. We've run out of time, but that was great.
Thanks a lot.
Thank you for time and input.
Thanks a lot. All the best.
Thank
Bye.
you.